Please print this handout if you haven't already. We're going to talk about preparing solutions. So sometimes you'll have to make up your own solution. And so there's one word that we're going to be familiar with, and that is a standard. So a standard solution is simply a solution where you know the precise concentration. And you can use a standard solution to make other solutions. That's one way to make a solution. But I'm going to talk about two different ways to make solutions. The first way is making it from a solid, and the second way is by dilution. So start with a solid. Here we have the Kool-Aid man. He's representing a good example of preparing a solution from a solid. So when you make Kool-Aid, you have your solid powder, which is your solute, and you're measuring out a precise amount of that solid. Then you add water, which is your solvent. And that's the basic idea of how you make a solution from a solid. Although in the lab, you're not going to drink the solution. Also, you're going to be much more precise with your measurements. So I have shown two devices that you use. This one you're familiar with already, the electronic balance. This is used to accurately measure the mass of the solute. So once you have the mass of your solute, you add it to this thing. This piece of glassware is called a volumetric flask. So the way they're set up is each volumetric flask has a line on it, just one single line, and that line is made to measure a precise amount. So you can have different sizes of volumetric flasks, but they're all made individually so that they measure out a precise volume. So you use the balance to measure out the mass of your solute, you add it to your flask, and then you fill it up to the line with water. Now you have a standard solution because now you know the precise concentration. The second way to make a solution is by dilution. So this would be if you already have a standard solution, but it's not the same concentration as you would like. You can take that standard solution and dilute it so that it has a different concentration that you would actually like to use. You start with a stock solution, which is basically just your standard solution. It's a solution where you know the concentration. Now, I threw in this word stock solution. That just means a solution that is in stock or something you have on the shelf. This is a solution that you would buy from a chemical supply company. And when you buy it from a company, it's usually very concentrated. So if you buy a 12 moles per liter solution, you can now take that and dilute it to the required concentration, usually 1 mole per liter or less. So you would take a certain volume of your standard solution and you would then dilute it in a volumetric flask. And one thing to remember is that when you're diluting a solution, the number of moles doesn't change. So if I take a certain volume of my standard solution and I dilute it, I still have the same number of moles. So I'm going to write that as the number of moles initially is equal to the final number of moles. What I start with is the same as what I end with. Doesn't matter what I change the volume to when I dilute it, the number of moles of my solute is still the same. And then I have to remember to calculate molar concentration, C equals N over V. Well, if C equals N over V, do your algebra, N equals C times V. Okay, so the number of moles is the concentration times the volume. So the number of moles that I'm taking from my standard solution is the concentration of my standard solution times the volume of my standard solution. And the number of moles of my diluted solution is the concentration of the diluted solution times the volume of the diluted solution. This is a formula that you need to know, and it's on your reference sheet. So this is the formula that you're going to use every time you are diluting a solution. So if you flip the page, we can do some examples. First example, calculate the mass of solid lye, which is just sodium hydroxide, needed to make 500 milliliters of a 10 mole per liter cleaning solution. Okay, so we have a volume, we have a concentration, and we're asked to figure out what's the mass. So if we're dealing with a concentration, let's start with our molar concentration formula, C equals N over V. Well, I know the concentration, and I know the volume, so that means I can solve for number of moles. Do your algebra, rearrange, N equals C times V. Plug in my numbers, and don't forget, change your volume to liters. And now we just do the math. So we need 5 moles of sodium hydroxide. I'm not done yet because I'm asked to find the mass. So this brings me to my other formula, the relationship between moles and mass. Remember, moles equals mass divided by molar mass. Sodium hydroxide is NaOH. So we need to figure out the molar mass of that. 1 sodium, 1 oxygen, 1 hydrogen. And if I rearrange my formula, I want to solve for mass, moles times molar mass. And then I can plug in my numbers. So we already know 5 moles, and the molar mass of sodium hydroxide is 40 grams per mole, which means I need 200 grams of sodium hydroxide to make this 10 mole per liter solution. Let's do the next example. Okay, water is added to 0.200 liters, so 200 milliliters of 2.40 moles per liter ammonia, until the final volume is 1 liter. Find the molar concentration of the final diluted solution. This is a dilution question, so we're going to use our dilution formula. C1V1 equals C2V2. And now I just have to plug in my numbers. So remember, what I've labeled with the subscript 1, that's my standard solution that I'm starting with. And subscript 2, that's the solution that I'm ending with. That's my diluted one. So what do I have? I have 0.200 liters of 2.4 mole per liter ammonia. This is my starting solution. That's C1, that's V1. I'm adding water, so I'm diluting it to 1 liter. So that's my final volume, that's V2 right there. And I'm asked to find C2. So I'm going to do some math, rearrange to solve for C2. And if you're having trouble with the algebra here to rearrange the equation, you can let me know in an email and I can help you with that. But now we just want to solve for C2. We're going to plug in our numbers for C1, V1, and V2 and just do the math and figure it out. And now I calculate. So the new solution is 0.480 moles per liter. And just a tip, if you're doing a question like this and you're getting a concentration bigger than your standard solution, you know something's wrong. Okay, next example. Student is instructed to dilute, there's the word dilute, so we know which formula we're going to start with. Instructed to dilute some concentrated hydrochloric acid to make 4 liters of a 10% solution. So we have a 36% standard solution, and we want to make 4 liters of a 10% solution. So I need to know what volume of the standard solution should they initially measure out. So this is a dilution question, so we're going to start with our dilution formula. And at this point, I'm going to stop. Our concentration is given as a percent, not moles per liter. Some people will be tempted to change this into moles per liter. However, you don't really have to. As long as the units for concentration is the same on the left and the right, this will work out. So we can keep it as a percent for C1 and keep it as 10% for C2. But what are we asked to find? It says what volume of hydrochloric acid solution should the student initially measure to do this? So it's asking for the volume of the standard solution. That's V1. That's what we want to find. So rearrange the formula to solve for V1, plug in your numbers, and do the math. So this means you need to measure out 1.1 liters of your standard solution, that's the concentrated one, and then dilute it with water to make 4 liters.